The Milky Way galaxy has over 100,000 million stars, and based on data from NASA's New Horizons space probe, we now estimate that our universe contains roughly 200 billion galaxies. Needless to say, the universe is indeed vast and filled with mysteries, which is why the deployment of the James Webb Space Telescope is definitely something that can really help us discover more. The Webb telescope is estimated to be 100 times more powerful than its predecessor, the Hubble telescope. In this video, we'll dive into what scientists believe are the 5 most important discoveries that the James Webb Space Telescope is expected to make. A key reason behind Webb's power is that it is primarily an infrared telescope, whereas Hubble is primarily a visible light telescope. Infrared is powerful because the oldest light in the universe is redshifted into the infrared. This gives the telescope the ability to peer further and deeper into the universe, seeing objects that are impossible for Hubble to observe. Additionally, visible light can't pass through dust, but infrared can. So, the James Webb Space Telescope will enable us to see through obscured and dusty regions of space, such as stellar nebulae. With this technology, what exactly are the 5 most important discoveries we can expect from the James Webb Space Telescope? Number 1. How the stars and planets are formed. Stellar nebulae, clouds of hydrogen and other gases, often obscure the formation of star systems within them. Although we do not know if our solar system is typical or atypical, the James Webb Space Telescope will enable us to observe the inside of these nebulae in greater detail than ever before, and see protoplanets and protostars forming. Understanding whether our solar system is typical or atypical might provide new insight on how we came to be here. Number 2. The appearance of the first galaxies and stars. The first several hundred million years of the universe's existence are shrouded in mystery. Because the early universe is only visible in infrared, it requires a telescope as large as the James Webb Space Telescope to image. The James Webb Space Telescope will collect data from these observations, and astronomers will use them to answer questions about how the first stars and galaxies formed in the universe, which will have profound implications for our cosmological models, especially regarding the great mystery of dark matter. Number 3. What the first black holes looked like and the reason behind why every galaxy have a supermassive black hole at its center. Every galaxy is known to have a supermassive black hole at its center, but we are still unsure about how exactly these behemoths form. Our current theories predict that the first stars may have collapsed to form these giants. However, we are not sure how they were able to get so big so quickly, forming the incredibly bright quasars that we can still observe over 13 billion years later. The James Webb Space Telescope should enable us to peer back and discover their origin story. Number 4. Possible existence of another planet like Earth and discovery of life elsewhere, both in the solar system and beyond. The James Webb Space Telescope will enable astronomers to detect the spectra of exoplanets and take readings of their compositions. This is important because it will enable scientists to determine whether or not some planets support life. If these planets are indeed similar to Earth, we may be able to detect biosignatures in the ratios of chemical elements that are different from what is geochemically normal. For instance, it's possible that we will detect signs of alien life in the TRAPPIST-1 system, or on the moons of Saturn and Jupiter. It may also be possible for us to observe biosignatures on Mars. Lastly, the true rate of universal expansion. In recent years, cosmologists have found discrepancies in different measurements of the rate of the universe expansion. This discrepancy is known as the Hubble tension, and it stems from making measurements of local galaxies and of the cosmic microwave background and comparing notes. But local measurements are obscured by dust, something that the James Webb Space Telescope can address. Newer and more precise measurements will reveal whether this discrepancy indicates new physics, or is simply measurement error. The telescope, which launched on the Christmas Day of 2021, has had to pass a series of milestones, including unfolding itself and aligning its mirrors. Now that the MIRI instrument, one of the main eyes of the telescope, is at the right temperature, Webb can begin a new round of test observations. This will help ensure NASA and ESA personnel that the instrument is working correctly and allow them to move toward the first true observations with scientific value expected to come this summer. The importance of the measurements coming from the James Webb Space Telescope for the fields of astronomy and physics can't be understated. Webb has the potential to completely rewrite our understanding of the universe, from how galaxies and stars are formed to the structure of planetary systems. And that's not even mentioning the possible scientific inquiry into signs of alien or intelligent life. And that's it for this video. Let us know what other cosmic historical milestones you want to explore next, and we'll see you then.